Hopefully we can get through this in 45, 50 minutes. I have a bad habit of either having too many slides or not enough, and in this case I think it's the former rather than the latter, but we'll see how we go. So a catchy title for a talk that is hopefully going to be of interest to some of you. First of all, just survey the audience a little bit. How many people are RabbitMQ users or are thinking about using RabbitMQ? Okay. There's quite a bit in the presentation really that talks about what RabbitMQ is, that talks about the AMQP protocol. I'll try and get through that quickly before I get to the other interesting stuff, but I'm guessing the reason you're here is that you will have read the abstract. And essentially what this talk, it came from the fact that late last year I put together a blog that discussed the polyglot nature of RabbitMQ. Everybody who's familiar with RabbitMQ is familiar with its ability to support the AMQP protocol, specifically 0.8 and 0.91 variants, or 8.1 and 9.0 variants thereof, I should say. It'll soon support 1.0 as well. But a somewhat less known fact about RabbitMQ is that via its what is a fairly powerful plugin architecture, it has the ability to support other protocols like MQTT, Stomp, and a few others that we'll talk about as we make our way through the presentation. Very briefly, background about me. The strange accent is because I live in New Zealand, down the bottom of the world. You can't go too much further south unless you want to get to the South Pole, and it's not really very nice down there, but it is nice in New Zealand. And you know, please come and visit our wonderful country. My introduction to Erlang came, I don't know, maybe 2008, 2009, something like that, really as a consequence of playing around with RabbitMQ and investigating AMQP. And I got interested in Erlang primarily out of some work I was doing to port Erlang to an old HP operating system, OpenVMS, that some of the older members of the audience may or may not be familiar with. So out of that work I kind of got to know a little bit about the inner workings of Beam and various other bits and pieces of Erlang, and I've kind of been trying to enhance my knowledge ever since. Anyway, so as I said before, basically what we're going to talk about here, and as per the abstract, is a brief overview of RabbitMQ and AMQP, the Advanced Message Queuing Protocol. It's primarily used by RabbitMQ, the reason Rabbit exists. We're going to have a bit of a discussion about RabbitMQ plugins. Why would you write a plugin? What are they good for? What can you do with them? What can't you do with them? Things like that. Talk about the plugin architecture. We'll talk about things called RabbitMQ boot steps, which are fairly fundamental to the operation of Rabbit when it starts up and things like that. It's a fairly complex beast when it boots up. There are a number of subsystems and interdependencies between those subsystems that need to be managed. And the developers have done a pretty good job of implementing a rather cunning mechanism, which the RabbitMQ boot steps to handle that complexity. Then going to talk more about the polyglot nature of RabbitMQ. And because I work for HP as an architect in hpcloud.com, I'm going to talk about just a little bit about setting up RabbitMQ clusters on HP Cloud and things like that. Okay, so AMQP. AMQP stands for Advanced Message Queuing Protocol. This is, as I say, it's a message queuing protocol, and it's an open standard protocol, much like TCP or HTTP or SMTP, things like that. It encompasses all the aspects of any good message queuing protocol that you'd expect to find. Reliability, queuing, security, scalability, all that good stuff. One of the key things about AMQP, however, and where hopefully it will succeed over perhaps earlier attempts at such things, is that what it all boils down to is the wire protocol. You can go out and write your own AMQP implementation as long as your code, in terms of how the bits and bytes end up flying around the network, as long as your code implements things that conform to the wire protocol as specified by the AMQP standard, you will be interoperable with any other implementation. It's a very key point. The standard doesn't necessarily say that thou shalt have this set of API functions in any AMQP implementation. What it says is thou shalt conform to this particular wire protocol. Okay, so I must admit, as I was listening to Joe's talk this morning, I couldn't help but think of some of the aspects that I'll hopefully remember to raise in this talk. AMQP was originally devised back around 2004-2006 timeframe. It was the brainchild of a man by the name of John O'Hara, who worked for JP Morgan Chase in London at the time. And he'd been through a lot of pain and suffering with a raft of message queuing technologies over the years and thought there had to be a better way of doing things. So he solicited help from an organisation in Belgium, iMatix. Many of you will have heard of AMQP, I'm sure, and Peter Hinchins, iMatix is Peter's company. So Peter and his team worked with John O'Hara to design the initial draft of the AMQP protocol and put together the first implementation, which was a piece of software called OpenAMQ. That was deployed throughout bits and pieces of JP Morgan, very successful project. As time went on and the protocol matured, they decided to essentially throw it out there to a working group, and today the working group comprises the organisations that I've listed there. Well, January 2013, I don't think there have been any new ones, may have been, but that's probably fairly accurate, I would imagine. What you will notice is that that working group comprises a number of technology companies and a fair number of what look like financial services organisations. And that kind of makes sense because AMQP has its heritage. It was born out of financial services. This is where John O'Hara worked. But it's finding applicability all over the place today, and we'll talk a little bit about that in subsequent slides as we move along. There's another organisation that I'm not going to mention because this is being broadcast and they'll probably get twitchy if they hear their name mentioned on the internet. But I would speculate that they're probably using some AMQP implementation for something, otherwise just keeping an eye on what these other organisations are doing. Short timeline of message queuing. Message queuing's been around for a long time. Way back as far as 1983, there were some rather crummy but quite interesting message queuing implementations. MQ series kicked in late 1990s. Microsoft around the mid-90s with their MSMQ. And like I say, AMQP, an open standard, kicked in around the 2004 timeframe. And there's been a lot of activity on the internet. It's almost like there's been some sort of resurgence in interest in message queuing as demands for massive concurrency, massive scale, need to sort of decouple in some way the production of data and the consuming of that information. So there's a whole new generation of users of developers starting to realise the virtues of message queuing. AMQP was born out of frustration. Like I say, John O'Hara, in his role, fairly senior technical role within JP Morgan Chase, they had one of everything. They had, MQ series and just about anything else that would queue messages, and probably a few things that didn't. And all of these things came with considerable license costs, and more to the point was that they spoke proprietary protocols. There was no open standard protocol spoken by these pieces of software. So every time you went out and did a new project, for some reason or other, a particular business unit might end up buying another middleware product that would have to integrate with all your other middleware products. They didn't speak the same language in any way, shape or form, and you would expend a lot of time and energy. A lot of money would be spent developing gateways, adapters, whatever you want to call them. And then, of course, ongoing, you need to provide support for those. So you've got additional cost in terms of supporting multiple skill sets, whole raft of factors. It just gets really, really ugly. So John had seen this within his own organisation and figured there really had to be a better way, which is where the whole idea of the AMQP protocol came from. And he wanted, big vision here, basically. His vision is that AMQP would become the solution for enterprise messaging, okay? From a protocol perspective, this is maybe a slightly old slide, but it maybe gets the point across. If you think about these somewhat older protocols and the use cases that they support, well, AMQP, one way or another, can accommodate those use cases and it can switch between them, okay? It's quite a broad protocol in that sense, flexible. Key components. Before I talk about this slide, what I should say is that this presentation really focuses on AMQP 0.8 and 0.91. AMQP 1.0, the specification was recently, maybe 4 months or so, 5 months or so, released, signed off by the working group. There are some differences between 1.0 and the earlier iterations of the protocol. What I'm talking about mostly here is those earlier iterations. And within that framework, the model is basically as I've described here. You've got an entity, a central entity, which is the message broker. Its job is to receive messages and make sure that those messages get disseminated to the relevant parties. Within the messaging layer, within the broker, you've got things called exchanges, queues and bindings. Within AMQP, for those who aren't familiar with it, you publish messages to exchanges. Exchanges then by virtue of bindings and routing keys, know how to deliver those published messages to one or more queues. Okay? Relatively straightforward concept. Publish to exchanges, exchanges route messages into queues based on certain matching criteria. Another thing that John O'Hara was aiming for with AMQP was that it should be useful to everybody. It shouldn't be, you shouldn't have to go and cough $50,000 for a license or something like that. I mean, this should be free stuff, open source, you can pay for support if you want it and so on and so forth. The whole concept of no job too big or too small. So you can go all the way up to your JP Morgan Chase type market data trading with several hundred servers and who knows how many topics and messages per second and things like that. Or you could just be some guy who happens to need message queuing for his local pizza shop or something because he's using a Raspberry Pi to take pizza orders, I don't know. Just going to very quickly go through some of the usage patterns that you find within these AMQP implementations, some of the message queuing usage patterns. I mentioned exchanges. Exchanges can be of different types within AMQP. They can be direct, which is essentially point-to-point messaging. Fan out and topic exchanges, which is essentially pub sub, publish subscribe. So for a direct exchange, principle is pretty simple. The publisher publishes a message to the exchange. The exchange basically does point-to-point messaging and routes that message into the target queue based on routing key and binding information. You might have one or more consumers slurping messages from that queue, and the AMQP implementation will typically round robin the delivery of messages to those consumers. More complicated, a fan-out exchange. The concept here is that any queue which is bound to a fan-out exchange will receive a copy of all messages. So publisher publishes one message in to the fan-out exchange. Any queues that are bound to that exchange, the exchange will pop messages into all of those queues. In this case, queues 1, 2 and 3 get a copy of every single message because those queues are bound to the fan-out exchange. Again, you can have one or more consumers dangling off the end of those queues, no big deal. Topic exchange, a little bit similar to the fan-out exchange, except delivery of messages by the exchange into the queues is based on some filtering, okay? So the routing key that comes into the exchange will be matched on a regular expression to determine whether a particular queue should receive a copy of a message. And again, of course, you could have multiple consumers off of each of those queues. So I could have, say, a routing key that contained information about stock quotes, and I could say that because I work for HP, I'm only interested in HP's share price, which thankfully is going up. And those messages might end up in Q3. Other people who are interested in perhaps HP and IBM shares, perhaps they would have a binding pattern that filtered on those two, and they would end up getting their messages in Q2 and so forth. Okay, really quick overview there of AMQP. RabbitMQ. RabbitMQ has been around for a while. I think 2006 first version was released. And it's estimated today that there are something like about 30,000 plus production deployments of that software around the globe doing all manner of interesting things. Within HP Cloud, we're based on OpenStack, and all the messaging, the nervous system within OpenStack, all the messaging within OpenStack is based on RabbitMQ, for example. So it's getting used all over the show in some pretty impressive ways. So RabbitMQ was probably the second implementation of the AMQP protocol, and it's written 100% in Erlang. I've said there it's the leading and arguably the most popular. I don't think there's too much argument about the popularity. Key point, 100% Erlang. Really nice. There's no 3GL code or anything like that in there. It is literally 100% Erlang. Nothing more, nothing less. As far as the actual product itself goes, the key components that the RabbitMQ guys have are the broker, of course, and they provide several client implementations, Erlang, Java, .NET, one or two others, and they also provide and support a number of plugins. In addition, there are, pick a programming language and there will be something or other, someone will have written something that will talk to RabbitMQ, speaks the AMQP protocol. There are client implementations in just about every language you can think of. So as I said, basically Rabbit was around about the second implementation following behind OpenAMQ. of the AMQP protocol. Since its inception, it's incurred very rapid adoption. I'm not sure why. It's a good product, it's well supported. Guys do an excellent job there, it's got a catchy name. And they've also actually done a good job, I think, over the years of incrementally adding new features. In 2010, they were purchased by VMware. But now you may have heard that EMC VMware are spinning off a company that will do things like Cloud Foundry and RabbitMQ and a few other bits and pieces. An organisation called Pivotal will be formed soon, and Rabbit will be part of that company. So I think it's 60-something or other % owned by VMware, but it's essentially an autonomous entity. Okay, a few more slides about Rabbit, and then we'll start talking more about plugins. RabbitMQ gets a lot from Erlang. If you look at the code base between RabbitMQ and OpenAMQ, for example, there's about an order of magnitude difference. Far less code in RabbitMQ because it does a very, very good job of leveraging all the good stuff that Erlang provides. Okay, this includes, you know, facilities around scalability through clustering. I mean, obviously you've got to write code to do some work here, but Erlang gives you a pretty darn good head start. High availability, various other bits and pieces. I should have worn my Rabbit t-shirt, but then everyone would think I work for them or something, which I don't. I can't quite remember when clustering was introduced, fairly early on in the piece, really, because it's something, of course, that a facility that Erlang has largely out of the box. RabbitMQ clustering allows you to, well, basically cluster multiple brokers, as many as you like. Reasons for doing this might be around availability, can also be around scalability in some instances. Key point, however, is that the cluster as a whole really has a common view, a shared view of messages, of the configuration and so forth. A queue might reside on a particular cluster node, but if you publish a message to another node and the queue's not on that node, doesn't matter, it will still end up in the right place, and similarly with consuming. Okay, so the cluster as a whole has a nice unified view of the entire configuration. But of course, you know, if you're publisher number 1 here and you publish a message to Q3 and this particular server goes offline, you've got a problem. So what the guys did there was they introduced high availability, where you can actually have HAQ replication. So you can say that I want this particular queue to be replicated across one or more of the cluster nodes. In which case, if a particular node on which a queue resides goes down, one of the other nodes can take up the slack and start dealing with the processing of messages associated with that queue. Obviously, this incurs quite a bit more chatter across the wire with the nodes talking to one another, but it's a pretty darn useful high availability feature. Rabbit, from probably 3 years back maybe, introduced some fairly nice monitoring tools. Originally it had a somewhat crude but very effective command line user interface for administering the RabbitMQ broker. A little while back the guys put together quite a good GUI based around MoshiWeb and a bit of JavaScript and bits and pieces like that allows you to have a look at what's going on within the broker to quite a low level, I might say, in terms of connections and channels that are running over those connections, exchanges, queues. You can administer in the sense of create, delete, modify settings via the interface, or you can use it as a tool to try and diagnose problems and things like that. One thing that I always point out to people is the little button down the bottom of the UI, which actually allows you to export your configuration. So if you've got some complex configuration and you're terrified about things blowing up in a puff of smoke, you can actually export that as a JSON file, and if the worst comes to worst, you can rebuild your environment and reload that config. There's a command line implementation of that tool as well. It's basically REST-based, right? So you could write your own administrative tools as well that utilize that RESTful interface. Security, won't spend too long on it, although it is a fairly important topic, obviously. RabbitMQ has a notion, well, AMQP has this notion of virtual hosts, and that's kind of the first level of security. You log in, what virtual host do you have access to? That's the first line of protection, I suppose. And then users and permissions, you can get quite fancy here. You could actually give somebody permission to create resources like exchanges and queues, but not give them any permission to read or write messages. Alternatively, you could have somebody who could write messages, so they could be a publisher, but they couldn't consume. You could give somebody read permission, they can consume messages, but they can't publish, and so forth. And you can get quite granular by applying regular expressions to apply those settings across sets of queues and exchanges and other resources. Okay, just to be completely non-biased here, just some other AMQP implementations. OpenAMQ I talked about. Unfortunately, the iMatics guys, for various reasons that we can discuss over a beer, pulled out of the AMQP working group some time ago. Cupid and Red Hat's offering are essentially fairly closely intertwined, and there's some organisations like StormMQ and SwiftMQ that offer AMQP as a service. There's another new one, what is it, Cloud AMQP, based out of Sweden, which is entirely RabbitMQ based AMQP cloud offering. Okay, RabbitMQ plugins. Like I mentioned earlier, well, as per the abstract, RabbitMQ supports plugins. It's a very powerful feature. It leverages some capabilities of Erlang that we'll talk about soon. And it allows you to do some pretty cool stuff to extend the broker. What can you do with plugins? Well, this is probably not a full set by any stretch of the imagination, but the key things you can do is you can incorporate support for other messaging protocols. And that'll be the focus of the next section of the presentation, really. You can create plugins that will provide alternative authentication mechanisms like LDAP or Kerberos. There's some people working on that at the moment. Implement alternative message stores. At the moment, essentially, RabbitMQ uses pure Erlang, ETS tables and various other bits and pieces for message stores. If you feel so inclined, you could write an alternative message store if you decided you didn't like the way the guys had done it, and you could run that up and cross your fingers. You could add extra functionality to the broker. The management plugin is an example of that, and there are plugins like the Shovel and Federation plugin that allow you to move messages around in different ways between RabbitMQ instances. Shovel, for example, is a good way to move messages across wide area network links that may be a little bit flaky at times or otherwise constrained. Last one I've got there is you can define other exchange types. I've highlighted the React one simply because there's a lot of React guys here. It's also one I've been playing with a little bit recently. Essentially with the React exchange, any message published to that exchange, in addition to being routed to one or more queues, will also be pushed off to React. Why would you write a plugin? Well, because you might have no other way of implementing the functionality that you want to implement, would probably be the most common one. With the plugins, you actually have some pretty low level, almost too much, I would say, access to the internals of Rabbit. You can tap into whatever functions are lurking around within Rabbit and leverage them within your plugins if it makes sense to do so. Obviously, it has some performance gains. Possibly in some instances, you might be able to write equivalent functionality that lives outside of Rabbit. But by packaging it with Rabbit, you're not only going to get performance gains because it's plugged straight into the VM there, it might also simplify things from a deployment perspective. You can create a kit that includes all your good stuff along with the core product. Like I've said there, I mean, this would be a workshop session if we wanted to learn how to write plugins. And the key points really are, if you're a skilled Erlang developer, you're probably going to find it relatively straightforward. And the RabbitMQ team do provide some pretty good documentation around all of this for writing plugins. And my favourite hobby, of course, is, well, what can I steal or borrow from what other people have done? Usual story, really. It is, however, pretty desirable to have some level of knowledge or understanding of the internals of Rabbit when you start writing plugins. Some of that knowledge may, I guess, come from studying what others have done. Be wary, some of the stuff I've done in this space. I did some work a while back with the Rabbit Hub plugin that we'll talk about. Basically provides a RESTful interface into Rabbit within certain constraints. But Tony Garnock-Jones, who originally wrote it, hadn't had an opportunity to bring it up to spec. And what we were finding as we were working through the issues was that we were being impacted by the fact that Rabbit had evolved as well. So do be wary of changes to the internals of Rabbit. They can have a flow-on effect into your plugins if you're leveraging the internals too much. Although that being said, to be honest, the core Rabbit API, if you want to call it that, is pretty stable these days and doesn't change too much. We're going to spend a little while on these things called RabbitMQ boot steps because they're fairly fundamental when you're dealing with plugins, and there's some interesting stuff here around using features of Erlang comes into play. Rabbit comprises a number of core subsystems. These core subsystems have interdependencies which can be fairly complex. Tony, who was one of the original Rabbit developers and also a fellow countryman, came up with this whole notion of the boot step. And basically, boot step relies on adding custom attributes into your Erlang modules and analysing those boot steps to figure out what all the interdependencies are between the various subsystems and ensuring thereby that all the subsystems are spun up in an appropriate order. Okay. So for example, just a really simple boot step here that you'll see within the RabbitMQ code. The recovery boot step. They all look pretty much like this sort of structure. There's a description, module function arguments, so that's what's going to run for that particular boot step. There may be one or more of those. Requires. So this boot step, recovery boot step, is not going to do anything until the empty DB check boot step has successfully completed. And once the recovery boot step is successfully completed, then the routing ready boot step can do its thing. Okay. Well, it seems simple enough. So, you know, why go to all this trouble? Why not just have a sequential list of boot steps and, you know, everything will be fine? Well, you probably could do that, but it does get quite complicated. Boot steps can be separated into groups, and one group of boot steps can be enabled by another. And you can also have boot steps that don't enable others. They're just kind of like markers to indicate that it's safe to go for the next step and things like that. Like I say, I mean, Rabbit, it's quite a complicated process spinning it up. And there's a diagram I'll show in the next few slides that illustrate the various subsystems and interrelationships and things like that between them that will give you a feel for the complexity associated with the boot process. Boot steps are important to plugins. For example, I've included one here from RabbitHub that I mentioned earlier. The RabbitHub plugin cannot do anything until routing is ready, okay? And routing ready itself will depend on other boot steps and so on and so forth. The RabbitHub boot step also has quite a sequence of module function argument things that it must go through to spin itself up and kick itself into life. One of which, interestingly enough, taps right into Rabbit internals to kick up a supervisor process. How does it all work? I've kind of described it already. You're all Erlang programmers, so I'm sure you've pretty much figured it out. Erlang modules can have attributes. You know, these can be exported functions, behavior declarations, whatever you like. So hyphen rabbit underscore boot underscore steps is just another attribute. Okay, so when the broker starts, basically it spins through all the modules that are defined in the loaded applications, looks for Rabbit boot steps, and out of them it builds a tree, a directed acyclic graph. Okay, and the graph, the DAG, is used to basically figure out from there what things need to be spun up in what order to make sure nothing trips over itself according to all those dependencies. Now this is described by Alvaro in his book on RabbitMQ in Action. If you're a RabbitMQ user and you haven't got that book, you probably should go out and get it. It's very useful. Good book. So Alvaro put together this diagram. It'll be a little bit out of date now in terms of current Rabbit versions, but it gives you some idea of what that graph looks like in terms of all the boot steps within Rabbit. I know you can't read it, that's not the point. The point is there's lots of little squiggles and circles and subsystems and all that sort of nonsense in there. Okay. I think I've covered most of this already. Booting up a sophisticated application like Rabbit is not a trivial task. Boot steps make it a lot easier. They make it easier to add new stuff like plugins and things like that. Okay. Right. Where this talk started was, as I said right at the start, today was I put together a blog that looked at all the different protocols. Well, looked at the different protocols that Rabbit is able to support in addition to AMQP. Okay, so the next few slides, the rest of the presentation, that's really what we're going to be talking about. Multi-protocol messaging. Why should you care? Right? Via RabbitMQ's powerful plugin architecture, you can implement this multi-protocol messaging hub that comprises a whole pile of open standards message queuing protocols. Why would you want to do that? Well, flexibility. You know, this whole notion, AMQP is pretty good, but the whole notion of having some sort of singular, unique, ubiquitous message queuing protocol that's going to properly satisfy all your message queuing needs is a fundamentally flawed view of the world. Some message queuing scenarios, you might be happy to trade speed for message loss. For example, when you're dealing with stock exchanges and quotes, you know, quotes are coming along every few microseconds or whatever. If you drop a quote or whatever, it's not a big deal because there's another one coming down the wire. When it comes to actually do a trade, you know, you're actually swapping some money there, you probably don't want to lose those messages. So you might want to use a different protocol or change some characteristics of how you use your current protocol. AMQP will actually handle that scenario reasonably well, so probably a bad example. But the key point is that all message queuing protocols, good message queuing protocols, share a lot in common, but some of them are designed specifically to operate better for particular use cases. Okay? Like I said here, the world is not uniform. Just as there would be advantages for me visiting a foreign country and being able to speak their language, the same goes for message queuing. For a particular scenario that you might find yourself in, needing a message queue, one protocol might be better than another. Okay. Any attempt to accommodate all possible scenarios is going to result in something losing out somewhere. You're going to have to make some level of compromise. Okay? Adaptability as well. Okay, whilst most good message queuing protocols share a lot in common, some, as I've said, are better suited to a particular task than others. Adaptability is also true with something like Rabbit, its ability to support these different protocols. Tomorrow you might decide that you've come up with a particular use case and there's no good message protocol that supports it, so you come out with a new protocol. Chances are we could write a plugin for Rabbit that would do the business and leverage the framework provided by Rabbit and Erlang to make it work pretty darn well. So some of the other protocols that are supported by RabbitMQ, this is not a complete list, but it's most of them. Stomp, MQTT, message queuing telemetry transport, reasonably new one. ZeroMQ, there's not been too much activity on that particular plugin lately. HTTP REST, I mean HTTP is not a message queuing protocol. HTTP has been twisted and contorted to do things that it was never ever intended to do. But still, whatever. WebStomp, I think there's a talk probably after mine that talks more about using RabbitMQ with WebSockets. And point down the bottom there that, like I say, most good message queuing protocols have many characteristics in common. Okay, and what this means is that you can map certain features. You know, one thing they have in common tends to be queues. So there are characteristics that you can map, and that's what Rabbit does with these various plugins. It's not perfect. So for example, can RabbitMQ plugin for MQTT implement everything that MQTT provides? Not really. It's not a perfect mapping, but it's more than adequate. So just for those who aren't familiar, Stomp, simple or streaming text-oriented messaging protocol, really simple protocol. ActiveMQ uses it. There are a few other implementations. If you want to write a client, you've got a spare afternoon, you shouldn't have too much trouble creating one. It really is very simple protocol. It's designed, as its name suggests, for sending around textual data, and it's pretty slick and nice and lightweight for doing that sort of thing. Stomp maps really quite nicely to the AMQP 091 model. So the Stomp plugin for RabbitMQ, you're getting pretty much full or close to Stomp coverage there. MQTT was originally devised by some guys within IBM, and IBM have put that out there for the world to have fun with. And it seems to be becoming very active, I'd have to say. The MQTT plugin for RabbitMQ is reasonably new, maybe a year, I suppose. The idea of MQTT, so this is a classic case of where I said that not all protocols are created equal. MQTT supports some bits and pieces that make it a really good choice devices that have to operate in high latency or otherwise constrained networks, okay? Some other protocols, like AMQP, you might have some issues there. MQTT has some characteristics that make it a better option in those sorts of environments. Number of clients available. Someone's written this, actually I think there's 2 or 3 Erlang implementations in various states of condition. RabbitHub is an interesting entity. It's basically a webhook-based pub-sub mechanism that provides you with an HTTP-based interface into RabbitMQ. So you can publish messages into Rabbit via HTTP, and you can consume messages via HTTP. Essentially, you specify, you subscribe to RabbitHub, providing a callback URL. When there's a message for you, RabbitHub will send that out to that URL. One of the key points that I haven't really mentioned, but I hope is reasonably obvious, is that it's not just, you don't just necessarily use the MQTT plugin. You can publish a message via one protocol and consume it via another, or you can consume it via multiple others if it's one of those fan-out or topic exchanges, for example. There's no restriction in that regard. So I could publish something via MQTT into Rabbit, and within certain constraints I could consume that via RabbitHub or via a Stomp consumer or an AMQP consumer or an MQTT consumer, okay? So you might have some people out there in the field with constrained network access or whatever with mobile devices. MQTT might be a great option for pushing data into your enterprise, and within your corporation or whatever within the local area network, that information might be disseminated via AMQP. All of these protocols are open standards, right? And one of the key motivations that John O'Hara had was what he described as middleware hell, where you've got all these proprietary protocols that just don't work together. And the point I'm trying to make down here, I think there's a significant difference between developing gateways and adapters to bridge proprietary message queuing technologies and having a core messaging technology such as Rabbit that can readily extend via plugins to facilitate multi-protocol communication between a set of open standards protocols, okay? You're not comparing apples with apples there. Like I say, I work for HP Cloud, www.hpcloud.com. That's our public cloud. And my job there, apart from knowing stuff about RabbitMQ, is to work with teams in the development of services that we can put on that cloud and offer to customers. It's entirely an OpenStack-based cloud implementation, which, as I mentioned earlier, relies fairly heavily on RabbitMQ for successful operation. Just to put together a few exercises for the blog post I wrote last year on this particular topic, I put together a 6-node RabbitMQ cluster, and I took a few risks here just to see in part how good our cloud was, but because it seemed like a fun thing to do at the time. I set up a 6-node RabbitMQ cluster spanning 3 cloud availability zones. Now this is a risky thing to do when you're in cloud because there's always the risk of getting a network partition which confuses the heck out of your cluster. You know, if AZ1 dropped off there, it would probably end up becoming an autonomous cluster and would have a 4-node cluster over there, and that will cause total confusion for people trying to publish and consume messages, of course. But that was what I set up just for fun. I also made a point of installing different plugins for the different protocols like Stomp and MQTT and RabbitHub in different availability zones. So I could publish a message into one of the nodes in AZ1 via AMQP, and I could receive it out the end of AZ3 via another protocol, okay? Doesn't matter. Just a few notes about the configuration if you're a RabbitMQ user. If you've set Rabbit up in the cloud before, then great. If not, then hopefully some of what I'm about to say will be useful. Key points, I can't really comment on Amazon, although I must admit I have helped people to set up RabbitMQ clusters on Amazon, but I can't claim to talk knowledgeably about it. But certainly within HP Cloud, and I would speculate any other OpenStack cloud implementation, key points listed here. Ensure that these ports are open, particularly 4369, otherwise your EPMDs aren't going to be terribly useful to you. And also you probably want to, instead, if you don't want to open up every port on your firewall, you might want to use inet dist listen min and max to constrain the range of the range of port numbers on which intra-cluster communication is going to occur. Okay. You've obviously got to open up 5672, which is the default AMQP port, and the different protocols that I've listed there, STOMP, MQTT, and RabbitHub, which uses HTTP anyway. You've obviously got to have those ports opened up. A few other points to consider. Everybody knows they've got to copy their cookie files around the place or have a common shared cookie, etc., no big deal. If you need some notes on setting up clusters on Amazon, then that's probably quite a good link. In fact, I think it's probably got some bits from me in there. Just thought I'd put up a few notes about RabbitMQ performance within HP Cloud. It's really pretty darn good. So these results were obtained here. I don't know if you can quite read the numbers from the back, but these results were obtained within HP Cloud using a 6-node cluster. Obviously, the sorts of results you get vary as a function of message size. So the graph here essentially is message size and on the x-axis, and rate of publication and so forth on the y-axis, the primary y-axis. So for small messages, we're hovering around 30,000 messages per second mark, which is pretty darn good, and obviously that drops off as message size increases. A whole raft of other variables come into play. One thing to keep in mind that I should mention here when you're dealing with these multi-protocol scenarios, like I said, not all protocols are created equal. And that's going to be particularly true of something like HTTP, which is inherently request response. It is one hell of a lot slower than AMQP. It is one hell of a lot slower than MQTT. It's slower than STOMP, right? So if you've got yourself in a situation where you're publishing messages flat out via AMQP to an exchange which is going to route a message to a queue that's going to be served by RabbitHub, then you might have a problem, because chances are there's going to be a build-up of messages. It's like at Joe's talk this morning when he was talking about the plumbing. If you're pouring water into a huge sink faster than it can drain away, it's going to overflow. And Rabbit includes a lot of facilities to save itself and make sure that messages don't get lost, and it's going to start applying a lot of back pressure to the person pouring water into that sink. So be aware of the limitations of the protocols in your mixed protocol environment in that regard. Cloud-imposed throttles are another one. For example, in HP Cloud, depending on the size of the compute instance that you've purchased and set up, there will be a throttle. You're not going to get the full 10 gig or whatever out of the NIC that's sitting in the host. You're going to get some percentage of that, okay? So be aware of things like that as well, otherwise you might be bitterly disappointed at the rate of message consumption or production. Just very, very quickly, how are we going for time? 5 minutes? I think I can probably do 5 minutes. If I have more coffee, I'll definitely do 5 minutes. Examples of multi-protocol messaging. I'm just going to very, very quickly blast through a few really simple examples, little bits of code, snippets of code. The slides will be up on the site, I'm sure, so you can help yourself and have all sorts of fun with it, and there's my blog site down here. Key point, though, is you can publish via one protocol, consume via another, etc., etc. Okay, so a real trivial example. This is an Erlang conference. We've got to have some Erlang code. So here's an Erlang client that's going to publish a message. This is direct exchange stuff. Essentially, actually, we're using the default exchange. So it's basically the message is going to go straight into the queue, which is called STOMP. And we've got a little STOMP consumer down here, again, written in Erlang, that will consume messages from that queue. Like I said before, you can have fan-out exchanges. So you publish a message to the exchange, and the exchange is going to route the message to any queue that is bound to that exchange. Okay, so we basically just changed the previous example to specify the exchange as AMQ.fanout, which is a default Rabbit exchange. We can now have a couple of consumers consuming messages from that exchange. Here's one in Python, and it's an AMQP consumer. Oh, here's one in Erlang that's a STOMP consumer. Doesn't matter that it's STOMP, and it certainly doesn't matter that it's written in a different language. That's completely irrelevant. But this one is talking STOMP protocol, this one is talking AMQP protocol. They'll both get a copy of that message, not a problem. Doesn't matter what protocol you publish with, consume with, you can mix and match. Add in an HTTP consumer, just to be smart. Here's a totally trivial little piece of Ruby Sinatra code, which essentially gives me an instant web server facility. sneaky little curl command to register this guy with RabbitHub, and I've now got myself an HTTP consumer which is going to be bound to the AMQ fan-out exchange. If I now publish messages in, this guy is going to start receiving them as well. This particular method here, the post method, is going to receive those messages. Okay, publish via Stomp and HTTP, same sort of carry on. You can publish via different protocols, really doesn't matter. Publish something here using a simple curl command to the AMQ.fanout exchange, simple curl command with RabbitHub, and any queues bound to AMQ.fanout are going to get a copy of that message. MQTT, again, some more Erlang. We love it. Okay, so I've complained to the guys at RabbitMQ that they don't make a big enough fuss about the fact that their software supports multiple protocols. I reckon it's a darn good feature. It's something I use all the time. It really is very useful. Allows you to handle a multitude of scenarios using the most appropriate message queuing protocol for the job at hand. That's pretty much it. Indeed. Lovely picture of home. Any questions? Either no one was listening or I covered everything.
Do you recommend using, as of your introduction, it must be possible to send the publish request with HTTP?
Yes. Yeah.
In that case, it means that we can put RabbitMQ in the front as a resource proxy, and then put some background.
Look, I mean, I've, in addition to RabbitHub, I mean, it's like an afternoon's work to write a module for Apache. I wrote one a while ago, called it mod AMQP or something, so I can do HTTP post requests to Apache, and mod AMQP will slug those messages off to Rabbit. You know, those sorts of things are not difficult to do. Would I recommend it? Well, I'd need to understand the entire problem before I made any comment in that regard.
I mean, common way of using resource proxy. As you, in your introduction, if I implement a plugin for consistent hashing and combine with consistent hashing, if I use HTTP binding, I think I might be able to use RabbitMQ as a resource proxy.
Okay. Yeah, I mean, I can't really comment. But what I would say is, you know, if you're familiar with using Rabbit, it's pretty darn easy to set these things up and play around. Consistent hashing exchange is kind of nice. And the guys are also working on another variant of that, which will sort of allow you to specify ranges as opposed to sort of more specific values with the hashing. But yeah, I can't really answer your question, I'm sorry.
Okay, I think our time is up.
Okay.
Thank you very much.
No problem.